What's up, everybody? In this video, we are going to learn how to use a distance sensor. The ultrasonic sensor in your kit uses sound waves and has a range of about 2 centimeters to 400 centimeters. The sensor emits an output and waits for the response to come back as an input. Start off by logging into Tinkercad using your course username. Select Circuits in the menu under your designs. You will see our basic setup circuit that we made in an earlier video. Hover over the circuit and click on the gear in the top right-hand corner. Select Duplicate. Click the name of our circuit in the top left corner and change the name to Ultrasonic Distance Sensor. Search the components using the keyword Distance and select the Ultrasonic Distance Sensor under Other Components. This has 4 pins and matches the one in your kit. The pins are VCC, or power, trigger, echo, and ground. There are other distance sensors that use the same pin for trigger and echo. Connect the VCC pin to power on your breadboard using a red wire. Connect the GND pin to ground on your breadboard using a black wire. Connect the trigger pin to pin 3 on the Arduino and echo to pin 2 on the Arduino. Next, we will add code. Click on the Code tab and ensure the text drop-down is selected. Fill out the information in the header of our code. Update the program name and description. The program name is Ultrasonic Distance Sensor, and the description is a sketch where we will measure distance using the ultrasonic sensor. Declare the variables. Create 3 variables, 2 for the pins and the other for the distance measurement. Type int trigger pin equals 3 semicolon and int echo pin equals 2 semicolon to define the pins. Type int distance equals 0 to hold the value of the distance measurement. Next, we are going to look at the code in the loop function to explain how to use the sensor. Type distance equals get distance, open bracket, trigger pin, comma, echo pin, close bracket, semicolon. Distance is the variable we defined that will be the measurement reading. GetDistance is a function that we will write to return a value from the sensor. The function has 2 parameters, the trigger pin, output, and the echo pin, input. Each time the Arduino executes the program loop, it will update the variable by calling the function getDistance. Add some code to debug. Add serial.print, open bracket, quote, the distance is, colon, space, quote, close bracket, semicolon. On the next line, add serial.print, open bracket, distance, close bracket, semicolon. And on the next line, serial.println, open bracket, quote, space, cm, quote, close bracket, semicolon. Notice that the first 2 serial statements are serial.print and not println. Serial.print will write lines side by side in the serial monitor. Serial.println will add a return, meaning the next serial statement will be on a new line. When we run our code, you will see the difference between the 2. Update the delay to 100 milliseconds. Now we need to write our function getDistance. Type int getDistance, open bracket, int trigger pin, comma, int echo pin, close bracket, open curly brace, close curly brace. Previously, when we created a function, we used the word void. This tells the program that no value will be returned from the function. Our getDistance function will return a value. So instead of void, we want to use int to tell the program we are returning an integer. Inside the curly braces, type pin mode, open bracket, trigger pin, comma, output, close bracket, semicolon. On the next line, digital write, open bracket, trigger pin, comma, low, close bracket, semicolon. Then, delay microseconds, open bracket 2, close bracket, semicolon. Next, digital write, open bracket, trigger pin, comma, high, close bracket, semicolon. Then delay microseconds, open bracket, 10, close bracket, semicolon. And last, digital write, open bracket, trigger pin, comma, low, close bracket, semicolon. Let's look at this code to see what's happening. For our sensor to work, we need to send a pulse, and then we will listen for a pulse to return. We just wrote the code to send a pulse. You may have noticed that we wrote the pin mode in the getDistance function instead of our setup function. This is because each time we execute the function, we want to clear any previous data. So we alternate between sending a low and a high value. When we send the high value, we send a pulse as an output. You may have also noticed our delay is in microseconds, so it is a very short delay. Now we need to listen for the return pulse. Type pin mode, open bracket, echo pin, comma, input, close bracket, semicolon. And on the next line, add distance equals pulse in, open bracket, echo pin, comma, high, close bracket, semicolon. Great. We told the Arduino the echo pin would be an input and updated the distance variable by executing a function called pulse in. Pulse in is a function that tells the Arduino to listen for a pulse on a pin. The parameters are the pin to listen to and the value. We use the echo pin on the sensor, and telling the Arduino high means it will wait for the pin to go from low to high and wait for the pin to go low again. Click Start Simulation and open the serial monitor. Click the ultrasonic sensor and move the little ball. Compare the values in the serial monitor with the distance showing above the sensor. So the values aren't the same. Why is this? The sensor returns a value of how many microseconds elapse between the output pulse and the input pulse. We need to convert that value to a measurement. Because the ultrasonic sensor uses sound waves, we can use this information to calculate a distance. The speed of sound is 340 meters per second, or 29 microseconds per centimeter. The pulse travels out and back to the sensor, so we need to divide by 2 since it will be half the value. Add the line distance equals distance divided by 29 divided by 2, semicolon. Next, we want to ensure we are returning the correct value from the function. On the next line, type return distance, semicolon. This will ensure that the function will return our distance variable. Click Start Simulation and open the serial monitor. Now you should see the values match. Awesome! We can now detect an object's distance. When you connect the sensor to the Arduino, test different materials to see how well they are detected. At the end of this video, you should have a better understanding of how an ultrasonic sensor works, and how to detect distances with the Arduino and an ultrasonic sensor.